Well, hello again. I've got another Sudoku I'm looking at today. This one's a bit unusual, though. I got a message from somebody called Zombie Hunter who suggested to me a series of their puzzles called XVVX. And on Logic Masters, they have a whole bunch of these. There's Arrows, Sandwich, Anti Night, Killer, Earthquake, Little Killer. I don't even know what some of these things mean. Life, Brood, Palindrome, a whole bunch of them, and most of them do not have enough solves to get a rating. This one actually they estimate. So when it's the blue stars, that's the setter has estimated what the difficulty is going to be, and then they'll turn red once it gets to I think 10 ratings. But it's only been solved 5 times, and I figured I'd try this one out and see how it goes. And maybe we'll find some new genre that would be good, and maybe we can get Zombie Hunter some more solves on their puzzles and get them rated. So we are in Penpa today, and oh, hold on, put that away for a second. We're gonna get that back up in just a second. So here's the puzzle. It's called XV Arrows VX by Zombie Hunter. Now, I think the main reason that they're not getting very many solves is because the rules seem pretty intimidating, but I tried to, you know, condense them as much as I could, and I don't think they're that complicated once you realize what's going on. So just stick with the rules. I don't think it sounds too bad. Now, I don't know about the difficulty of the puzzle, but I think the rules aren't as bad as they initially seem. So, um, essentially, we have normal arrow Sudoku. We are doing a 0 to 8 Sudoku today. So it's not 1 through 9, it's 0 through 8, which is one of the reasons we're in Penpa, because you can put zeros in a cell in Penpa. So that's going to make our arrows different. Now, this looks a little funky. This is just a 2-cell arrow. I think they probably didn't know how to put that in Penpa correctly. But that's a 2-cell arrow right there, so a 2-cell circle. So you could have, 20, for example, which you couldn't normally do in an arrow Sudoku. So the 0 adds an extra dimension. All right, so then, the center cell is just a minimum. It has to be less than the ones surrounding it. That's standard stuff. So the trick is with the V and the X. So we're going to break it down real simple. There's 2 options for V and 2 options for X. One of the options is our normal V and X, where these 2 would sum to 5, these would sum to 10. So that's one option. That's your normal stuff. So the trick or the twist is the V can be an inequality. So this could be, 1, 4, right? Because they sum to 5, like usual. Or it could be 8 and 7, because it's just showing it's, the greater than symbol, pointing at the bigger digit. That's it for V. Now, X seems a little more complicated, but I don't think it's too bad. So it can be the sum to 10, 3, 7, like usual. But those could also be 3, 7, and it's a multiplication problem with the result directly after it. So 3 times 7, for example, or 7 times 3, would equal 21. You could also have something like 3 times 2 equals 6. So, and if it's a vertical one, like right here, you could have 2 times 3 equals 6 that way, or 7 times 3 equals 21. So that's it. That's all the rules. There's no negative constraint. So I don't think it's too bad once you kind of understand the options. Now, they did provide examples, so I'm going to put that up on the screen here. I'm not going to go through all of these examples, but I'm going to put these on the screen, and if you want to pause the video and look through these, they've kind of explained all the different possibilities. Ignore the 9. If you're using F puzzles, you got to use 9s. We're not going to do that. We're just going to use Penpa, use zeros. That we don't need the extra confusion. So you can ignore the stuff about the 9s for F puzzles, unless you really want to use F puzzles. But there you go. That's it. That is the rules. I'm going to get rid of the examples now. So if you wanted to read through all those, hopefully you paused it, or you can go back and pause it. I am going to try this now. Zombie Hunter has estimated it as a 3-star difficulty, so I'm hoping it's not too bad. I think the main difficulty probably is going to be just kind of getting an understanding of the rules. So link in the description as usual, and I'm going to give it a try now. Start the timer. Here we go. So, I mean, we've got a 5 up here to start, which, right, so our two options are either the sum to 5, which would give us a 0 there, or it's an inequality, in which case it would have to be something smaller than 5. So we know it's one of those. I'm thinking the 2-cell arrow down here maybe is a good place to look. So we've got 4, because the arrows are just normal arrows. There's nothing different about the arrows, so we know how to do those, basically, is my thinking. So what's the maximum these could be? These 4. So we've already got a 5 up here, and we can't use a 9, so 8, 7, 6, 4 would be the maximum, which would be 25. So this can be at most a 2. Now remember, it could be a 0, I think. I think that'd be allowed, like a 0, 9 or something. I mean, we can't, well, we can't go that small, can we? Well, definitely not. Look over here. We have a 6L. Even using a 0, the minimum we could do here is 0, 1, 2, 3, 4, 5, which is 15. So this can't be a 0. So it's a 1 or a 2. Now, could it be a 1 is the question, because if this is a 1, we can't put a 1 over here. So we would have 0, 2, 3, 4, 5, 6, which would be 20. So if there's a 1 here, you can't put a 1 in here. Is that right? 2, 3, 4, 5, 6 is 20. Yeah. Yeah, so this has to be a 2. Okay, that's not a 2. Right, and so since this one takes up the whole row, now our row is not, normally a row in a Sudoku adds up to 45. But with 0 to 8, it's going to be 36, because we got 45, but we're not using the 9, so 45 minus 9 is 36. So 36, so what could we put in here? This could be up to 8. Let's say this was 8. The arrow would sum to 28, plus the 8 plus the 2 gives us 38. You can't do that. You can only get up to 36. So 7's probably going to have the same problem, right? 27 plus 9 is 36. So you could do that if you had a 0 there. 26 plus 8 is 32, so you'd have a 4. 25 plus 7 is... Wait, 26 plus 8 is 34, which would have a 2, sorry. 25 plus 7 is 32, which would have a 4. Because the 36 is the total, remember? Yeah, it's just going to go, every time we go down 1, we're going to go up 2, aren't we? So 23 would have an 8. There we go. So those are the possibilities. But this way, what did we say the maximum was? 8, 7, 6, 4, which is 25. So we actually can't have 6 or 7, which means we can't have 0 or 2. So these are our options. Now, so I'm sure we have to have an 8 and a 7, right? Like 6, 4, 3, 2 is not even going to come close to 23. Because we got to be at least 23. 6, so 6, can we do it without an 8, I guess would be the first question. 7 and 6, 4, 3 is 20, so no, we have to have an 8. Can we do it without a 7? 8, 6, 4, 3, 14 is that 21. Nope, so we have to have a 7. Now, can we do it without a 6? Because the issue is we've already used the 5 here, so that's limiting our options. So 8, 7, if we don't have a 6, it'd be 4, 3. That's 22. So no, we have to have 8, 7, 6, which is 21. So we can't do 23 because we'd have to have a 2 in here. We already got a 2, so we can't have 3, which means we can't have 8. Is that right? Let me make sure. 25 and 7 is 32. You'd have a 4. 24 and 6 is 30. You have a 6. Yep. Okay. So we know there's a 4 in one of these two. It's either 4, 6 or 5, 4. This is gonna need to have, so it's already 21, so it's gonna have to have 3 or 4 with it. So it's 6, 7, 8, uh, with a 3 or a 4. 6, 7, and 8 with a 3 and a 4. So 6, 7, 8, 5. So these are 0, 1, 3, 4 as well. Now this could be, could that be a 0? No, because the options are either they sum to 5, in which case you have to have a 5, or it's an inequality, which it has to be bigger than this one. So this one can't be 0. Can that be 3? Yeah, 3. No, no, because we have a 3 or a 4 down here. So if this is a 3, you can't do a sum to 5, so you'd have to have the 4 for the inequality, but you have a 3 or a 4 down here. So this one can't be a 3. If these are 1 and 4, the 3 is down here, and that's a 0. Yeah, but this could be like 0, 1 or 0, 3 or 0, 4. Yeah, there's quite a few options there. Okay. Oh, that's interesting. So I think this has to be a normal x because, yeah, because the if it's a multiplication problem, the result has to be below it, and there's nothing below it. So this is actually a 4, 6 pair. That's interesting. Maybe we should look at this arrow up here. Yeah, yeah. Okay, so it's a single digit arrow. Normally, you can't have a 4 cell arrow with a single digit result because the minimum of 4 would be 10. 1, 2, 3, 4 sums to 10. So we know there's a 0 in this one. Now, after we put a 0 in, wherever that is, it essentially turns this into a normal 3 cell arrow, doesn't it? So this still has to be 6, 7, or 8. And this is going to have a 1 on it then, because 6, 7, or 8 in 3 cells has to have a 1. So we know there's a 0 and a 1. Now, what do we know anything about this? If it's a 5, if it's a normal V, it sums to 5. 1, 4, 2, 3. It can't be 0, 5. If how can that be an inequality? Oh, oh. So I think the V's that are in rows have to be a normal V. Because if it's an inequality, it'd have to point one way or the other, and we don't. So really, only the vertical ones could be an inequality. This has to be a normal V. So it can't have a 0 because it'd have to have a 5 with it. So it's got to be 1, 4, or 2, 3. And we know they sum to 5. So the other two have to be a 0 plus, you know, 6 minus 5, 7 minus 5. So it's 1, 2, or 3. So these are a 0 with a 1, 2, or 3. This was 1, 4. You'd have to have a 2 or a 3, which would get you to 7 or 8. These are, but if it's 2, 3, you could have a 1. Yeah, so you could still have 6 there. Oh, but you can't have 6 because we've got the 4, 6 pair. This can't be a 6. So these are 5. These other ones have to be a 0 with a 2 or a 3. Which then means this can't be 2, 3. This has to be 1, 4. And these are a 0 with a 2 or a 3. 7 or 8. Now, we could still have a 0 on here, couldn't we? So this isn't our normal 3-cell arrow. And this one could be an inequality. So even if it was, 1, 2, and 4, these wouldn't have to be 1, 4, because this could be 4 and 2, or 2 and 1. Oh, we can't have a 4, though. We can't have a 4. So if this is 7, it can't be 1, 2, 4. It would have to have a 0. If it's an 8, we could do 1, 2, 5, couldn't we? So we don't necessarily know that there's a 0 on here. Okay. So where else do we look? We know over here there's going to be a 7 or an 8, a 2 or a 3, and a 6. Okay. Maybe can we do something in the middle here? Oh, so I don't think. Yeah. Okay, that's interesting. So an X. Think about an X. If it's a sum to 10, you can't put a 0 or a 1, right? Because 0 would have to have a 10, and 1 would have to have a 9, and we're only doing up to 8 this time. So you can't put a 0 or 1 on an X if it sums to 10. Now, if it's a multiplication problem, well, 0 times anything is 0. So you'd have to have a 0 because it's going to be in the same row or the same column, the result. And so you can't do a 0 on an X. And a 1 times anything is itself. And again, you're going to repeat a digit. So you can't put a 0 or a 1 anywhere on an X. So these have to be 0 and 1. And because of the minimum thing, we know it's that order. It's interesting. So can we use that anywhere else? We can't put a 0 or a 1 on there. And we can't put a 0 or a 1 up here, actually. So these have to be 0. We could put a 0 or a 1 down here, though, couldn't we? No, we can't put a 0 on here because it has to have a 5. So this has to be the 0, actually. We can't put it up here because we need a 0 on the arrow. We can't put it in here because you can't put a 0 on an X. You can't put it here because it's not an inequality because it's not tipped sideways. And a 0 would have to have a 5. So that's the 0. This is not 0. And now, oh, that could still be a 1, though. I was going to say this can't be a 1 anymore, but this could still be a normal V. If this is 4, you'd have 1 and 3. This is 3, then you have 1. Yeah, okay. But the 1 can't be on here, and it also can't be up there. So the 1 is definitely down here. We can't make this. This has to be 2, 3, or 0, 5, actually, because it has to be a normal V. And it can't be 1, 4, because there's already a 1 or a 4 in that one. It can't be 0, 5, because we have the 0 over here. So that has to be a 2, 3, which gives us the 0. This is not 0. There's a 0 down here. Obviously, the 0 can't be in the circle. But it could still be either one of these. Now, right here, I was tempted to say, because it can't be the bigger one, but it could be a 0 with a 5, couldn't it? If it was a normal V. 5. That would make this one have to be a multiplication problem. Because if you put a 5 on an X, it has to be a multiplication problem. Because you can't do 5 and 5. Now, 5 is interesting for multiplication too, isn't it? Because, so the problem we were having with the 1 and the 0 is you were going to repeat a digit. But 5 times an odd number is going to have a result that ends in a 5. Like 5 times 3 is 15, 5 times 5 is 25, etc. So 5 times an odd number is going to have something 5. And you'd repeat the 5 in the row or in the column. You know, here 5 times something would be something 5. So the 5, and in this box, the 5 is going to have to be on an X somewhere, isn't it? So it has to be a 5 with an even number. Which is then going to have a 0. So it's going to have a 2-cell product and a 0 kind of skip a, so you're going to have 5 with an even, skip a cell, 0. So there's going to be a 0. So this one can't have a 5 because you'd have to have a 0 right there. And we already have a 0 up here. So this can't have a 5. Let's put 5s in here. So 5, we put a 0 there. This one would put a 0 down here. So all of those still seem possible. All right. That's not as helpful as I thought it was going to be. At least not yet. Maybe it will be eventually. This could be a 5. Yeah, this one could still be a 5. You'd have a 0 down here. Okay. This one, this has to be an inequality because we can't. Yeah, because we can't do a 0 in either of these. So we can't do 0, 5. We can't do 2 and 3, and we can't do 1 and 4. So this has to be an inequality. But could it be a 2 or a 3? Because remember, these three cells are a 7 or an 8, a 2 or a 3, and a 6. Could this be a 2 or a 3? It would have to have, it can't have a 0. Could have a 1, couldn't it? Yeah, it could still have a 1 down here, so this could still be a 2 or a 3. Okay. 2, 3, 2, 3. So there's got to be at least one of them has to be down here. A 2 or a 3. But it could be all the way, I mean, it could even be this one over here. It doesn't necessarily have to be on the V there. What do we have in here for possibilities? Because we can't do a 0, 2, or 3 anymore, so 1, 4, 5. We can't go above a 5 because we've got a 3 cell. Oh, we could still have a 0 here, couldn't we? 0, 1, 6 would get us to 7. This one can still be a 0. So these could be up to 6. But there's a 7 or an 8 here, and the other one has to be down here. These can't be 4 or 6. I keep forgetting. 4, 6 down here. So these can't be 0, 2, 3, 4, or 6. They have to be 1 and 5. They have to be 1 and 5. So that's 6. And then we would need either 1 or 2 to make 7 or 8. But we can't use a 1, so it's got to be 2. So that gives us an 8. That means this is 3. This has to be the inequality then, because we can't put 2 and 3. So this is, oh, we got 4 and 1. These are going to be 6 and 7. What do we got left down here? 0, 3, and 7. Obviously, this has to be an inequality. So this one can't be 7. That one can't be 0. This one can't be 0. This is a 0. The 0 there eliminates that option. So these are a 3, 7 pair. Which means that neither of these x's can be a 3, 7. If they're a sum to 10, and this one over here, I mean, it can't be a multiplication because what are you going to multiply to get 3 or 7? It would have to be 1 times 3 or 1 times 7. So these have to be a normal x. So we can't do 2, 8. We can't do 3, 7. It's got to be 4, 6. These are not 4 or 6. So now we've got 0. We've got 2, 8, and 3, 7. 2, 3. Oh, and 5. And 5. 5, 5, 5. So this could be. This can't be 3, 7. Right? What are our options here, actually? It can't be 3, 7. It could be 2 times 5 equals 10. It could be 2 and 8 because of the normal x. Could we put a 3 or a 7 on there? Is there any way? No. No, because there's no way to do 3 or 7 with a multiplication problem to get to 10. And yeah, so that can't. So that has to be 2, 8 or 2, 5. So there's a 2 on there for sure. This is not 2. 2, 8 or 2, 5. Can this one be? No, back to what we were doing before. If the 5 is on the x, it has to be a multiplication problem. You've got to have a 0 in its result, but there's a 0 here now. So this one can't be 5. So we know this is 2, 5 because the 5 and the 2 both have to be on this x. 2, 5. 2 times 5 equals 10. We still got 3, 7, or 8 here though, don't we? So Yeah, there's probably quite a few options there. Do we know? Oh, this can't be an inequality because this would have to be smaller than 1. It would have to be the 0. So this has to be a normal v. This has to be a 4. So this can't be a 4. And now we know that wherever the 6 is in here, it's going to be part of a multiplication problem because it can't be 4 6 to sum to 10. So there's a 6 in here that's part of a multiplication problem. Could it be there? 6 times 3, you'd have to have 18. You can't do the 1. 6 times 7 would be 42, which you can't do. And 6 times 8 is 48, which would repeat an 8. So you can't put a 6 right there. So the 6 has to be one of these. Now, 6. Let's try it down here. 6 times 2 would get you 12, which you can't do. 6 times 3 would be 18, which would work. Can't do 4. 5 would be 30. Can't do 30. 6 times 7 is 42. You can't do 42. 6 times 8 is 40. So if it's 6 is down here, it's got to be 6 times 3 to get 18, which I think works. If it's up here, 6 times 2 is 12. Can't do. 6 times 3 is 18. You can't do that because you need to have a 1. Can't do 6 times 4. 6 times 5 would be 30. Oh, that might work, actually. 6 times 7. Nope. 6 times 8. No. So either 6 times 5 up here to get 30, or 6 times 3 to get 18, I think are the options. Now 6 times 5 gives us 30 up here, but then we'd have a 3 there. Yeah, and we could do 3 and 7 and make it a normal x, couldn't we? That seems possible. 6 times 3, 18. This is 1, 8. You'd have 5 and 0 there. There you go. Okay. That's the problem. So if you do 6 times 3 equals 18, you're going to have the 5 up here, but the 5 also has to be in that row in this box then. If this is 6 and 3, you have to have the 5 up here. But if 6, 3 equals 18, you have to have the 5 up there. So you can't put the 6 down here. This has to be 6 and 5 makes 30. And now this can't be a 0 because it can't be bigger than a 3, and it doesn't sum to 5. So the 0 has to be over here. 5 times 6 equals 30. This is not 3. So this is either 3 times 7 equals 21, which we can't do. You can still do 3, 7, though. 3 times 8. 3 times 8 is still a possibility there, though, isn't it? So these are 2, 7, and 8. So maybe we need to look at down here. These could be 2, 8 if it's a normal x. That would be possible. Otherwise, 2 times 7 would be 14, and you've already got the 4 there. So these have to be a normal x. That's a normal x up there. Let's see. This could be a 2, or it could be almost anything bigger than 3. So yeah, that's got a lot of options. 2, 8. This is not 8. Oh, the 7 now. So that gives us the 3 and the 7. This is not 3 or 7, so it's an 8. These could be 3 and 7 with a 6. They could be 4 and 6 with a 7. They could also be, what, 6 and 7 with a 4. Yeah, 6 times 7 is 42, so that still would be possible. This one can't be a 7, though. So this could be 6 times 7. It could be 3 and 7. It could be 6 and 4. I don't think this one can be a 3 anymore. And it can't be a 6 either. So it's either 6, 7, 6, 4, or 3, 7. Okay. What about up here? We've got quite a bit. We've got 0, 2, 3, 5, and 6 already in this row. So we need 1, 4, 7, and 8. These can't be 8s, so the 8 is over here. These are 1, 4, and 7, so these are 0, 3, and 6. Which leaves 1 and 5 over here, I think. The 4 up there gives us the order of the 4 and the 6. Should have seen that already. 1 and 5. What about right here? If this is a 1, yeah, so if this is a normal V, you'd have to put a 4 with the 1, which you can't do. But if it's an inequality, you'd have to have a 0 with the 1, which you can't do. So this has to be a 5. Now, this can't be a normal V because you'd have to have a 0. So this is going to have to be an inequality, and it can only be 1, 2, or 3. Oh, the 6. 7, 6. 2 or 3. 1, 2, 3. Okay. So these are 1, 2, 3, and 7 to finish off the column. These are 2, 3, 5, and 8 to finish off the column. This could still be a multiplication problem here. It could be 2, 3 to get to... Actually... Yeah. It could be 2, 3 to get to 6. Or it could be 3, 7. So this can't be an 8. There's no way this can be... Well, and it can't be an 8 anyways. You can't put the largest digit possible on a 2-cell arrow. Normally you can't put a 9 on a 2-cell arrow. Well, we don't have 9, so now you can't put an 8 on a 2-cell arrow. Speaking of arrows, that reminds me we didn't look at this arrow up here. So 3, 6 can't do because you'd have to have 9. So this is going to have to be 8. That's a 5 and a 6. The 8 gives us the order of the 2 and 8 down here. 3. So can we have a 1 here? No, we can't have a 1 here because you can't put a 1 on an X. We already decided that. 0 and 1 can't go on X. So there's an 8 here. There's a 1 there. This could be 2 and 3. Could it be 5? No, can't be 5. Because you'd have to have a 5 if it was a normal X, and you can't multiply anything by 5 with a 1-digit result. So this is either 2 times 3 equals 6, or it's 3 and 7, and it's a normal X. 3, 7, these would be 1 and 2, yeah. I think, oh, but these are 5 and 8 either way, aren't they? Yeah, because we've got a 2, 3 pair in the column, so. Yeah, these could still be 2 and 3, couldn't they? Okay. This one can't be 2, though, because of the 2 over here. Okay, so... Oh, we know what these are now. These are 2, 6, and 7. This one, if this is a normal V, this would need a 3 to go with a 2. If it's an inequality, you'd have to have a 0 or a 1, and we can't. So this can't be a 2. So it's a 6, 7. It's a normal inequality. So 2, 4, 5, 6, I suppose. Can't be 2. Excuse me, can't be 2 because of the 2, 3 over here. Can't be 0 or a 1 or a 3. A 2. Can't be a 7 because it has to be smaller. 4, 5, 6. Oh, the 2 has to be here, doesn't it? Because the 2, 3 here are ruling it out of those. So this is a 2, which makes that a normal arrow. These are 4, 5, 6, and 7. 7. So these have to be an 8. There has to be an 8 on here, and we can't put it with a 2. So it has to be a multiplication problem. Okay, so it has to be an 8 with a 4, 5, 6, or 7. So I know we don't know which one of these two is the 8, but I'm just going to write it this way for right now just to test things. 8 times 4, 32. Can't do that. 8 times 5 is 40. You can't have a 0. 8 times 6 is 48. You'd repeat an 8. 8 times 7. So it's got to be 8 times 7. So these are 7 and 8. These are 56, which makes that a 7 and a 4. These are not 7. So these are, this is 1, 3, 4 through here. And these have to be a normal V. So they have to be 1, 4. That gives us a 3. And now we're going to know these have to be 4 and 7. So it could be, ooh, it could be either way still, though. Because you could do 6 and 4 for a normal x, or you could do 6 times 7 equals 42 if it's the multiplication x. But we know this is a 1 either way. These are not 1s, so 4, 7, 2, 5. These are not 6s. We got a whole bunch of pairs through here. This one's probably going to fix that for us. Oh, we know what this is now. Right, because we did 8, 6, 4, 7, which is 25. So this is a 5, which is going to do 2 and 5. That 2 is going to give us 6 and 2. And then, huh, is that all we're going to get from that? Yeah, looks like it. Okay. I thought maybe we were going to get some more of these pairs figured out, but oh, this one right here. Yeah. Okay, if this is an inequality, what's going to be bigger? 1 and 4 can't be bigger than 4 or 7. So this has to be a normal v. So this has to be 4 and 1 and 4 and 7 and 8 and 7. There we go. Now we've got 0, 3, and 8 to complete the column. And this one can't be 0 because of the 0 over here. This column needs 0, 3, 1, and 6. This one again can't be 0. We can't do a 5 over here, so we got the 8 and the 5. All right, let's see. What are we doing here? 4. This can't be a normal x because it would need a 6. So this is a multiplication, and this has to be 2, 3, or 8. These are 2, 3, 8. So if it was 4 times 2, it could be 8. So we could do 2, 8. Oh, these can't. This one has to be a 3 because of the 2 and the 8. 3. This can't be 3. This can't be 3. So now it's either 4 times 2 equals 8, or 4 times 8 would have to be 32. So this has to be 4 times 2 equals 8. This one is not 2. This is not 8. That puts the 8 up there. 2, 3, 2, 3. This is the 2. So there's definitely a 2 on. Oh, we already knew there was a 2 on there. All right. What are these? 1, 4, and 7. 1, 4, and 7. Well, this arrow can't be a 1 sum, obviously. Can it be a 4? It'd have to be 3 and 1. No, it can't be, because these are 0, 5, and 6. So this can't be a 4, because there's no way to make a sum of 4. So this is 7. That gives us the 4 and the 7 there. That 4 gives us the 6 and the 4 down here. That 4 gives us 1 and 4. This is not 1. This is not 1. It's 7. This one can't be 5. We have a 0, 6 pair, which is really weird to say. This can't be 5. And, oh, we can't have a 0 either. So this is 6. 6. And this can't be 6. We get a 1, 3 pair, okay? So, right here, the 7. The only way to make 7 here is 5 and 2. This is not 2 or 7. This is 3, which 2 times 3 equals 6. That works out well. The 5 is bigger than the 1. This has to be a 0. 5 is bigger than 0. This is 6. 6, 0, 1. So this is 3, 0, 1, 3, 0. And then we just need 3 and 2. Hooray, we did it. Congratulations, your solution is correct. All right, that was XV Arrows VX by Zombie Hunter. I don't think that was too bad. 3 stars is about right. I think the main difficulty is just the rule set. And now I'm pretty sure, I didn't really look through the other XVVX puzzles, but I'm sure the XV and VX ambiguity is the same thing. Yeah, it looks like, in fact, they've got the same example things for each of them too. So it's just that same kind of ambiguity with the other constraints. So I might have to try some of those other ones now that I understand the rules. That was fun. That was a neat idea. The ambiguity can sometimes be frustrating to try to um, determine on puzzles with ambiguous rules, but this wasn't too bad because really you're it's more limited than you think it's going to be. Because, like, for example, the V's, once I realized a V in a row has to be a normal V, there aren't really that many that are inequalities. Um, and the X's are pretty limited once you start doing multiplication because anything times a 5, has to be an even. You can't put a 0 or a 1 on a multiplication. So it's not as ambiguous as it initially seems, I guess. So there you go. That was XV Arrows VX by Zombie Hunter. Let me know what you thought of that puzzle, and tell me if if you were able to solve it, if you had trouble, if you like this rule set, if you think it's overly complicated unnecessarily, whatever. I'm sure Zombie Hunter would appreciate some feedback too on whether to keep making these or not. So there you go. I'm gonna go record my solve, and we'll see if we can get this puzzle to a rating. All right. That's all I've got today. Thanks. See you again soon with another puzzle. Bye.